Our next presenter is Peter Kokh, and he's also speaking about an aspect of the triggering events for going into space. And his presentation is the human expansion Triway into space. And if you want to self-introduce, I'm sorry,
Sure.
being rude.
I've been around for a while. I'm currently president of the Moon Society, but I'm president of the Milwaukee chapter of the National Space Society forever, and I've been editor of Moon Miners Manifesto now in the 21st year. And people think of me as a moon man, but I'm actually interested in that.
What's your focus?
Huh?
What's your focus?
I focus on the moon, but my newsletter, one issue a year is on Mars. Everything fits together. It's not a question of either or. This presentation comes from, I think I was listening to Bob Zubin, and I got an idea. Right now the public perceives us as divided. Some people want to go to Mars, and some people want to go to the moon, and some people are concerned with the killer asteroids. And I thought, there's a common thread here. We all want to protect Earth and humanity. Now, this isn't about urgency or anything. This is about how we can see all these different efforts as on the same page. And if the public sees that, we have the inspiration behind those who want to go to Mars, those who want to go to the moon, those who want to look up for NEOs, is basically the same thing. You'll understand that. So a Triway to space. We're concerned with near-Earth asteroids, with creating another human civilization on Mars, and with the moon. We want to protect Earth from being destroyed, or civilization and our biosphere from being destroyed by a killer asteroid. Just in case we don't succeed, we don't want all our eggs in one basket, so we want to have a viable civilization on Mars. And meanwhile, there's another danger, which is probably the greatest danger of all. We need to protect Earth from ourselves. And that's where going to the moon for resources to help solve the energy generation problem, and helping clean up our environmental degradation makes sense. The moon is also a place to put, the safest place in the solar system to put archives of everything we've done. We'll get at that. So the three principal human space expansion pathways, each focused on one of these imperatives. Now, survival. Planetary defense. Now, I know I have to say that I understand that this is important, but you have to keep in mind the degree of danger is not great near term. If you look at the major impacts that we have here, the killer impact 65 million years ago, Sudbury, north of Lake Ontario, is 2 billion years old, and that was a major impact. That's Behringer Crater in Arizona about 50,000 years ago. Manitoulin Lake, that I think 100,000, 200,000, I don't remember.
Oops. Sometimes it goes a little bit fast. There you go.
Goes too fast.
Yeah.
Okay. There are other dangers we face that, if we're talking about, let's say, look at the next 25,000 years. There's some there's some danger, you know, an asteroid may hit us. But on the same scale of time, there are other serious dangers. This is La Palma Island in the Canaries.
Laser pointing?
Okay. And this whole western half is unstable. A volcanic interruption would dump 3 cubic kilometers of dirt into the Pacific, create into the Atlantic, create a super tsunami, the likes that we haven't seen in historical times, which would pretty much wipe out all the cities along northern Brazil and eastern coast. Yellowstone, the super volcano, you can see it's erupted 3 times. You can see the areas of devastation, almost the whole entire western United States. Goes off about every 600,000 years. The last time was 650,000 years ago. So we're a little overdue. And then the next ice sheet. Well, you know, this is where you have to do a reality check. You know, how dangerous are the killer asteroids? One thing we know for sure, in the next 25,000 years, Canada and Northern Europe are going to be wiped clean off the map by another ice age. And nobody in Canada or Northern Europe is losing a night's sleep over it. So, but I'm not saying that we don't want to be concerned about killer asteroids. We need to do the least expensive things first. We have to, first we have to identify them all out there and then tag them. The Planetary Society has a project going, how do you best tag an asteroid so we can really keep track of it. We need to characterize each of these objects as to their internal cohesiveness and structure. And then on the basis of which population group poses the greatest threat, prioritize development of and testing methods of deflecting these objects. So, you know, some people say, oh, we got to develop nuclear bombs and go and push these things out of the way. You know, that's not an efficient way to tackle it. One thing at a time. We should be busy doing things, especially the first 3 objects, first 3 items there are things we can do now for very little money. We're beginning to know now that a lot of asteroids are like bean bags. You punch them in the middle, they don't deflect, they just rearrange themselves around your impact. So we really have no good idea how to redirect these objects yet. We need to learn much more about them, and we need to identify them. Near-Earth asteroids and comets are not only possible threats, but they're also sources of resources we may need. The engineering metals, the precious metals, volatiles that the moon is not too well endowed with. So while we're trying to figure out how to deflect these things, maybe we want to deflect them into orbits where we can harvest them. Now, establishing a viable colony on Mars. Mars is in many ways the most Earth-like planet in the solar system. Total land surface the same as ours, the day is similar, a thin atmosphere, and apparently a lot of water locked up in permafrost and underground aquifers. So perhaps Mars could someday survive cut off support from Earth. That's a long way to get there, because if you look at how we could support opening the Mars frontier, where we can see that on the moon you could make things to sell either directly to Earth or to markets in Earth orbit. It's very difficult to see what Mars could make except to sell to the moon. So I think Mars is most viable if the moon is in the picture. establishing a viable human colony on Mars. Stephen Hawking is concerned about this. The survival of the human race is at risk as long as we are confined to one single planet. So sooner or later, something could get us. It could be an asteroid collision, a nuclear war, or just our own stupidity in wrecking our own environment. Now, synergies. How could Mars help in the asteroid problem? A vantage point for identifying and tracking Earth approaching asteroid chunks that also approach Mars. Some of these asteroids may contain resources that will be of value to Mars. And early civilization on Mars could be also threatened by an asteroid impact. And some of the techniques used to develop to redirect Earth approaching asteroids might also be used to direct comets on collision courses with Mars, if this would prove useful in adding Mars water reserves. I'm not in favor of that at all. There's enough water there. Saving Earth from ourselves. The consequences of greenhouse gases, well, it's not only global warming, we've got melting of the glaciers. This shows the area in Florida that could potentially be flooded. See Miami gone there. Shows areas of Manhattan, of India, mostly Bangladesh, Australia. Australia, by the way, considers itself to be suffer early on, early target, Louisiana. But it's not only flooding, we're going to have large-scale desertification, desiccation, dry periods, forest fires. So we're going to be suffering from all sorts of things, and very inconveniently, a lot of the people of this planet live in the areas that are going to be hit hardest first. Ways the moon can help: solar power, satellites made from lunar materials. There was a study done that at a penalty of 8% more mass, solar power satellites could be made from lunar materials, and as opposed to lifting all this mass up off the Earth. There are a lot of technologies here that have not been tested. We think we can do power beaming, but we have to do power beaming through the atmosphere. We don't want to use wavelengths of microwaves that are going to cook everything in the atmosphere, obviously. Solar power arrays on the moon itself. This is a Dave Criswell plan. You'd have large parts of the moon on each limb covered with solar arrays, and they would provide power by relay. And then there's helium-3, which even though some people think we are nowhere near fusion, I asked Dr. Jerry Kolchinsky, who's the guru of helium-3, well, it seems like we've been 30 years away from break even for the last 30 years. He says, nope, we're about 3,000 times closer than we were. Helium-3 is the ideal fusion fuel. The ignition point is much higher, but it produces only, it doesn't produce neutrons, it produces just protons, and in other words, electrically charged particles which can be used to produce electricity directly. Now we produce electricity indirectly through heat. A fusion plant would, especially one burning helium-3, you could live inside it and get less radiation than you do from the we hear from bedrock below our feet. Helium-3 is something we have on Earth only through nuclear weapons production, but on the moon, it's there in the upper layer of the regolith, thanks to solar wind blowing on the wind on the moon for the last 4 billion years. If you extracted helium-3 from the regolith and you wanted 1 ton of helium-3, in the process you would produce 6,000 tons of hydrogen, 3,300 tons of water, 500 tons of nitrogen, 1,700 carbon dioxide, 1,600 methane, 1,900 carbon monoxide, and 3,100 tons of regular helium. All the things which could be used on the moon for life support, for cryogenics, for fuel, and so on. It's been estimated if you could take the shuttle external tank to the moon and fill it with liquid helium-3, had we the plants on Earth to burn the fuel, that one shipload would provide all the power, electric power needed in a year in the United States.
Wow. Well,
There-
there's commercial needed.
The thing, we are working on the technologies. The government has stopped, the Bush administration stopped all thermonuclear research, fusion research. But behind the scenes, people are still working on it. There is enough helium-3 in the upper 6 feet of 2 meters of the lunar surface to bring, let's say, the world up to our standard of living and keep it there maybe for hundreds, maybe 1,000 years. By the time we need more, there's so much more in the atmosphere of Uranus, where it's especially stratified, that as far as we can imagine into the future, we could well set. This shows where helium-3 is richest on the lunar surface. It's especially, for some reason, the soils that are rich in ilmenite, which is a titanium, iron, oxygen mineral, seem to hold more helium-3. Okay. So the moon has resources to support an industrial economy which could support this kind of an operation. We can make building materials on the moon. If you look, let's see, I think on Sunday, Dr. T.D. Lin will be here. He's the one who's 20 years ago proved that you could make cement from lunar regolith. And he's continued to work on it, even after funding from NASA stopped, and he's developed now a steaming process that makes the concrete even stronger, use a lot less water. Now he's retired, and he and his colleagues in several universities in
5 minutes.
in Taiwan are working on all the equipment needed to do this on the moon. So that's by far the most advanced of the.
What's the presenter's name?
Lin, L-I-N. He'll be talking Sunday. Living comfortably on the moon. I made a tabletop moon base on a 36 by 80 home corridor, and it's just a large homestead, 3,600 feet homestead, and I show how, if we cover ourselves up with, so many feet of moon dust, it's the same thing as the blanket that our atmosphere provides. If you freeze out the atmosphere, you get about 15 feet of oxygen, nitrogen, snow, and it provides the same protection. but we can, we know how to bring in the sunshine inside. We know how to, we've been developing gray water systems so that every module that has a toilet will pre-treat its own waste. There are a lot of technology we know how we can make ourselves comfortable there. So anyway, synergies with the moon and planetary defense. Remote control telescopes on the moon will help identify more and smaller asteroid chunks and do a better job of tracking them. Lunar industries will be a market for minerals mined on those asteroids. And the moon itself holds the shattered relics of hundreds of thousands, millions of asteroid impacts, so we can learn something from that too. Synergies between Moon and Mars. Modular architectures, including modular life support advisory systems, life support technologies, spacesuit development, mining processing and construction technologies, modular factory systems, all sorts of things. They're both different worlds, but in the respects from which they differ from Earth, they are more similar than different. And the two worlds would have quite a bit of trade between them. So I think both goals fit. So anyway, as a potential Moon-Mars trade routes. And then another thing, as I mentioned, the moon is the best place to, meanwhile, to archive everything we have. The lava tubes on the moon that are still intact have been untapped for 3.8 billion years. There's nowhere on Earth we can archive anything that is going to withstand nature, even for a couple 100,000 years. So different groups support the planetary defense thing, opening Mars and opening the moon. I think if we'd all sign an agreement saying, hey, we're all on the same page and we agree to focus on the different things that we do best, the public and Congress would get the idea, hey, they do have their act together. Maybe we should listen. Thank you.
Okay, do we have questions for Peter? Oh, come, we must have questions.
Yeah.
Yeah.
You mentioned the equivalency between the 15 feet of regolith as the protection as being comparable to the 15 feet of atmosphere if it's all frozen and concentrated in one spot. But that is to protect you from what? From
continental, well, yes. I mean, our atmosphere, burns up most of the micrometeorites, and very little will get through that much regular heat also. But more so cosmic rays, solar flares, and just simply by providing thermal equilibrium. A lot of people are worried about the moon. Oh, the temperature gets so low at night and so high. With no atmosphere, that's a surface effect. Just a surface effect. You get down a little bit, and it's the same temperature all around. Just like here on Earth, we dig down a bit, and we get the same temperature all around. So that's one of the keys to thermal equilibrium.
the moon doesn't have the equivalent of the Van Allen radiation belts to filter out some of that.
And of course, we now know that there are large networks of lava tubes. They form in lava sheets and they form in shield volcanoes. Mauna Kea, Mauna Loa, is just loaded with lava tubes. But so are all areas on Earth where we have lava flows over extensive areas. And they're ready-made shelters. So, at first we might burrow into the surface, but eventually there's so much volume already there protected. We might just go down there, especially take our industrial parks and things that need a lot of area.
You go down there and find a museum.
Yes,
That would be the-
someone else thought of that.
That would be the best. You know, sometimes I like to throw this in, I mean, you know, people, what about in, if, you know, our human civilization is so new and so short-lived that the idea that somebody would be visiting us now instead of hundreds of millions or even billions of years ago is sort of absurd. So let's say if we've ever gotten visited in our history, and it was only once, the chances would be almost astronomically small that it would have been within the lifetime of our civilization. So say somebody came by in, you know, 100 million years ago. Where could they leave a calling card? Anywhere they left one on Earth would have been wiped out by geology and biology. On the moon, it could be there. That's just a teaser.
I think I saw that in the film.
We can take one more question.
That was 2001.
How about this mining thing? You said this mining of the...
Well,
What's some of the...
at the, you know, the people who are really interested in this are Jerry Kolchinsky and Harrison Jack Schmidt. They work together, and the center of this is the University of Wisconsin in Madison. And they have been doing at least notional studies of the kind of things, harvesters which would crawl over the ground, pick up the upper couple yards of moon dust, heat it to 600 degrees Celsius, harvest the volatiles and separate them later, and then redeposit all the moon dust right back where it was. And you would skip any crater of size, but chew up everything else. So, you know, you had a little crater that a yard wide or a couple of yards wide, that would disappear, but anything big wouldn't. So you would never notice a difference from Earth. And that would be solar powered. So we run
What were the two gentlemen's names at the University of Wisconsin-Madison?
Jerry Kolchinsky, Kulchch.
I-N-S-K-Y.
Yeah, and Jack Harrison Schmidt.
Jack Harrison Smith?
Harrison Schmidt, yeah.
Harrison
He spent
Schmidt.
some time in Arizona and sometimes in Madison.
Harrison Schmidt was an Apollo astronaut.
Yeah.
You're plugging the hometown.
Huh?
You're plugging the home state,
Yeah.
Wisconsin.
Well,
I'm kidding. I know Wisconsin's there. I was just following Anita's good humor.
Yeah, okay. Well, and that runs us out of time. Peter, thank you very
Okay,
much.
all
There's
right.
your presentation. Appreciate it, Peter.
You heard that.